Okay, with problem number 21, we have inequalities now. And I'll write this out a little bit so hopefully it'll be a little bit easier to see. And we solve inequalities exactly the same way we solve equations, except for when we multiply or divide both sides by a negative number. Then we're going to flip the direction or change the direction of the inequality. In the meantime, we have a problem with x on both sides, and so we're going to pick on the little guy. So I'm going to get rid of the negative x, which is the smallest x. I'm going to add x to both sides. And 3 is less than or equal to 3x minus 7. At this point, I'm going to add 7 to both sides. And so we get 3x. 10 is less than or equal to 3x, or we could say 3x is greater than or equal to 10. Divide both sides by 3. And x is greater than or equal to 10/3. Now usually we write these from left to right, so I'm just going to write it the way that I just read it. X is greater than or equal to 10/3. You can't just move the things around. You have to change the direction also. 10/3. And so that's going to be our solution to problem number 21. All right, for problem number 22, we have another inequality, but here it has some of the characteristics of our other types of problems with equations. And that is that we have fractions, we also have some distribution. So when we have fractions, the first thing that I want to do, I want to multiply both sides by the least common denominator, which is just 4 here. And so I'm going to have 2 times 3 minus x over 4, and 3 times 10 on the other side there. And that's less than or equal to 3 times 10. All right. Now what did we multiply by 3? I have no idea. It should be a 4 there, right? My apologies for that. So when we multiply both sides by 4, what's going to happen is that on the left side, those denominator, the 4 in the numerator and denominator will cancel out, and we'll come back to just having 2 times 3 minus x less than or equal to 40. Now we'll need to distribute on the left side 6 minus 2x less than or equal to 40. Now our x's are in place already, so I'm just going to subtract 6 from both sides. And when I do, I am going to get negative 2x is less than or equal to 34. Now at this point, if I were solving an equation, I would have to divide by negative 2. And when you divide or multiply both sides by a negative number, that's the first thing you want to do, is to change the direction of your inequality. And it becomes x greater than or equal to negative 17. So when you say multiply or divide both sides by some negative value, you are going to change the direction of your inequality. And we'll go on to problem number 23. Now 23 is a lot simpler than the previous problem. We have the x already on one side. We're going to subtract a 5. Subtract a 5. Remember that you're subtracting 5 here, not adding. We'd have negative 3x less than or equal to negative 15. Now we haven't multiplied or divided both sides by a negative number, so we don't change the direction just yet. But here we go. Now we're going to divide by negative 3. And so right away I'm going to flip the sign, and negative 3 over negative 3 is just x. And then negative divided by negative, 15 over 3 is positive 5. So x will be greater than or equal to positive 5. Now we haven't been graphing these solutions, but if we were, we'd make our number line. The only thing we need is a 5 here. Because it does have an equal sign, we're going to have a solid circle at 5 and then shade to the right. So that's all we would need to do if we had to graph the solution as well. Alright, on problem number 24 we have what we call a compound inequality. We have two less than signs together. Now generally, if we have a compound inequality, we'll always be working with less thans. We never use a mixture of less than and greater than, and we don't use greater thans. We always use a less than, so that the smaller numbers are to the left, larger numbers are to the right. And to solve these, we solve them essentially the same way. We're just going to do the same thing to both sides, to all sides I should say, to all parts of it. We want to isolate the x, so we add 5. But we're going to add 5 to all three sides here, so that we end up with 13 is less than x is less than 26. And again, if we were going to graph that, we have a 13, we have a 26. Because there are no equal signs, we should have open circles, and we're going to graph in between them. A compound inequality always graphs in between 2 points there. And we'll go on to the final problem in this set. Alright, so number 25. Once again, we're going to do the same thing to all three parts. The goal is to get the x by itself in the middle. First thing I want to do, subtract 7 from all sides. So we have negative 5 minus 7. That's not negative 5 minus negative 7. It's negative 5 minus 7 or negative 5 plus negative 7. Either way, we're going to end up with negative 12 less than 2x. And then we have less than or equal to on the left side, on the right side, and that's 13 minus 7 is a positive 6. Divide all sides by 2, all parts by 2, and we end up with negative 6 is less than x, which is less than or equal to 3. Finally, if I want to graph that, my endpoints are negative 6, positive 3. I do have an open circle at negative 6, but a closed circle at 3, and I'm going to shade in between those 2 points. And that's it for this and for this worksheet.